Astronomers have detected flares erupting at the edge of Sagittarius A star, a supermassive black hole lurking at the centre of the Milky Way galaxy. New observations reported in the journal Astronomy and Astrophysics show clumps of gas swirling around at about 30% the speed of light on a circular orbit just outside the black hole's event horizon. It's the first time material has been observed orbiting so close to the event horizon, the point of no return beyond which material falls forever into the black hole's singularity. The authors used the gravity instrument on the European Southern Observatory's VLT, or Very Large Telescope, in Chile. Gravity observed flares of infrared radiation coming from the accretion disk around Sagittarius A star. The flares originate from material orbiting close to the black hole's event horizon, making this the most detailed observations ever taken of material orbiting so close to a black hole. While some matter in the accretion disk, the belt of gas orbiting Sagittarius A star at relativistic speeds, can orbit the black hole safely, anything that gets too close is doomed to be pulled beyond the event horizon and in turn disappear from our universe. Relativistic speeds are those which are so great that the effects of Einstein's theory of relativity become significant. In the case of the accretion disk around Sagittarius A star, the gas is moving at roughly 30% the speed of light. The gravity instrument combines the light from all 4 telescopes of the VLT into a sort of giant optical interferometer to create a virtual supertelescope 130 meters in diameter. Earlier this year, Gravity and Symphony, another instrument on the VLT, allowed the same team to accurately measure the close flyby of the star S2 as it passed through the extreme gravitational field near Sagittarius A star. Those observations provided the first direct evidence of the effects predicted by Einstein's general theory of relativity in such an extreme environment. During S2's close flyby, strong infrared emissions were also observed. It was during those observations the authors were lucky enough to notice the 3 bright flares around the black hole. This flare emission is caused by extremely highly energetic electrons, originating magnetic interactions in the very hot gas orbiting close to the black hole. It exactly matches the theoretical predictions for hotspots orbiting so close to a black hole of 4.3 million solar masses. You're listening to SpaceTime. I'm Stuart Gary. NASA's Dawn spacecraft has suddenly gone silent, ending its historic mission to study time capsules from the solar system's earliest chapter. The end happened when Dawn missed scheduled communication sessions with NASA's Deep Space Network on Wednesday, October the 31st and Thursday, November the 1st. After the flight team eliminated other possible causes for the missed communications, mission managers concluded the spacecraft has finally run out of hydrazine, the fuel that enables the probe to control its orientation in space, allowing it to point its communications antennas towards the Earth and to position its solar panels towards the Sun. The Dawn spacecraft was launched 11 years ago to visit the frozen worlds of Vesta and Ceres, the 2 largest objects in the main asteroid belt between Mars and Jupiter. The images and data that Dawn collected from both Vesta and Ceres are critical to understanding the history and evolution of the solar system. The Dawn spacecraft was launched back in September 2007 on a 7 billion kilometre mission to explore Vesta and Ceres. These 2 worlds are on opposite sides of the snow line, the distance from the Sun, where it's cold enough for volatile compounds such as water, ammonia, methane, carbon dioxide and carbon monoxide to condense into solid ice grains. The 1,218 kilogram spacecraft achieved orbit insertion around the asteroid Vesta in July 2011. Vesta is the brightest asteroid visible from Earth, and it contains some 9% of the total mass of the asteroid belt. The 525-kilometre wide world has a differentiated internal structure, typical of terrestrial planets, with a metallic nickel-iron core surrounded by a rocky mantle. After some 14 months of surveys, Dawn left Vesta and travelled to its second target, the dwarf planet Ceres, arriving in March 2015. Ceres has a diameter of 945 kilometres, making it the largest object in the main asteroid belt, containing a third of the belt's total mass. Ceres appears to be differentiated into a rocky core and an icy mantle, and there are indications that it may have a remnant internal ocean of liquid water under its icy crust. If that's the case, the mystery is what heat source keeps it liquid. Ceres' surface is a mixture of water ice and various hydrated minerals such as carbonates and clays. Dawn Chief Engineer and Mission Director Mark Raymond from NASA's Jet Propulsion Laboratory in Pasadena, California, says the historic mission has changed astronomy's understanding of planetary science. He says Dawn was the first spacecraft to visit a dwarf planet, the first to go into orbit around 2 destinations beyond the Earth, and one of the first to use an ion propulsion system.
When you work on a mission this long, it feels like a part of you. I've been a space enthusiast since I was 4 years old. Getting to work on a mission like this, it's a dream come true. To me, Dawn is truly Earth's first interplanetary spaceship. No other spacecraft has gone to a distant body, gone into orbit around it, maneuvered there, then broken out of orbit, traveled elsewhere in the solar system to another alien world, and gone into orbit around it. And it does that with ion propulsion, which I first heard of in a Star Trek episode.